Oh, good evening, everybody. So, about a month ago, I had a little experiment that I did with the Midnight Solar PowerFlow 5 server rack battery. I ended up taking that battery and trying to see if I could move my pastor's golf cart with it. So after that video was released, my friend Roland from Roll2 Videos put me in contact with Vatrer, and they make golf cart batteries. And that's what we have to take a look at tonight. Oh, mercy. So we have the Vatrer 51.2 volt, 105 amp hour golf cart battery to take a look at tonight. So let's get started. So this is their 105 amp hour golf cart battery. This is not the heated version. They do have heated versions. We might actually get a chance to take a look at one of those later. And so when I looked through their listing, they actually have a full conversion kit for the club car golf cart. And so I asked them to send that over to me, and they were more than happy to. This 105 amp hour battery can actually do a 200 amp discharge, and it can actually surge up to 400 amps for up to 35 seconds. And that's just crazy, thinking that much power can come from one battery. If we look at the dimensions on this battery, if we go from mounting bracket to mounting bracket, we are about 19 3/4 high, including these handles here, about 9.5, and depth, this lid actually overhangs a little bit. So we need to go, depth on the lid is about 12.5 inches. And this thing, this thing is heavy. It comes in at about 102.5 pounds. So if we take a look at the top, we do have nice heavy-duty spring-loaded handles. We've got our 51.2 volts, 105 amp hour listing, which gives us a total of 5.3 kilowatt hours. On the front face, we've got the Vatrer logo. The same thing is on the back. On the right-hand side, we don't have anything over there, but you can see the mounting slots, different mounting slots for different types of carts that you're going to be installing in. And then on the left-hand side, we have the business side of the battery. So we've got our positive and negative terminals, on and off power switch. This does have Bluetooth built into it. And because this is a sealed battery, they actually have the antenna sticking out the side. So you can get a decent Bluetooth signal and not have the metal case impeding the signal. There's an RS-485 port. And we also have a vent in the event that something in the battery does vent. This doesn't become pressurized. It will vent out the side. So this kit does come with a lot. On the left-hand side, we've got app instructions. We've got the manual. We have a wiring diagram. We have a note about what to do when you first receive the package. Our warranty card. This does come with a display that you can mount on your dash, as well as cabling to wire up that display. We've got multiple size nuts for battery terminals and connections. We have battery terminal covers. This does come with a 48 volt battery charger specifically designed for lithium iron phosphate and this battery. We've got the power cord for the battery charger, and then a quick disconnect for the battery charger to go to the terminals on the battery. So the very first thing to do when you get this battery, they actually give you this instruction card, which tells you when you first get it, they recommend connecting the display to the battery to make sure that all the information reads properly, that you basically don't receive a dead battery and install it that way. So they recommend connecting that display just to make sure that everything is good before you spend time installing it into the battery. So we'll grab the display real fast and the cable. There is a quick connection side for the display and that cable. And you just push till you hear a click. Now we've got our connection. And then this is the data end for the RS-45 terminal on the side of the battery. So we'll pop this top, and there are alignment pins in there so that you can slide this in and get it aligned properly. Twist and tighten it down. So we will press the power button. That is a nice click. Inside, there was a relay click when I pressed this power button. And if I look at this display, it doesn't come on its own. This power button, you press it to turn the display on. So we can see that this battery was received 48% state of charge. No current voltage 52.72 volts. And the temperature 72.5 degrees Fahrenheit. We'll switch to page 2. Discharge is on, charge is on. 1 cycle, status is normal. And page 3. And I do like this because now we can actually see the individual cells and the individual cell voltages on this pack from your dashboard, which is going to be pretty neat. Okay, so when you press the power button, it does cycle between the pages. Can I press and hold it to turn it off? Doesn't seem like it. Here's a closer look at the wiring diagram that they give you, showing you how everything needs to get wired up, including how to stack your connections on the battery terminals. Now, this does not come with the 12-volt converter. I did order it just so that it's all the same hardware in the event that my pastor has any problems. It's all from the same place. And so that'll give us the ability to have the key control that 12-volt power, which will be nice. I know I could get one for a lot cheaper, but for ease of installation, it was worth the cost. Manuals gives you some information, kind of tells you what the specifications are, kind of goes through what some of their testing was for this battery, because it's different than a regular server rack battery, because this has to deal with a lot of vibration and potential drops in them in temperatures as well. And so yeah, you can see just dimensions again. It's kind of neat that they give you the pinout for the RS-45. So just a handful of pages in the battery. Pretty basic, but it gives you what you need to know. And we'll look at the app at some point. But again, that's nice to be able to have Bluetooth connectivity. Yes, you can see a lot of the information on the display, and I don't imagine you're going to be changing many values, but having that information to where you can easily see what's going on from the battery standpoint. At first, I was thinking it would be nice if you could press this to turn the battery on and off, but then I thought, do you really want somebody walking up and pressing this button and turning your actual battery off? Probably not. So before I go through and charge this thing up completely, let's pop the top, take a look and see what it looks like inside. What's the build quality of the pack? We'll then go through, do a full charge and then a discharge cycle, make sure we can get that 105 amp hours. And I'm probably going to end up doing the actual installation in a separate video just to make things simple and clean. But let's take a look at the battery. So before we do anything, obviously we'll go through and we'll press the power button, turn it all off. I heard a relay click. I'm assuming it opened up. Might as well use the handles, right? Pop the top. Woo! So underneath the lid, this does have an insulation barrier so that if it does get crushed, it's not going to be pushing metal on top of the bus bars. So that's very nice to see from the build standpoint. I do like how clean this looks. It looks like PCBs with bus bars built into them, as well as it looks like, I'm guessing these might be their temperature sensors, but the bus bars have a bend in them to allow for expansion. Then along the back here, they have a bus bar. So they did dip this, it looks like, in some kind of isolation compound, maybe even rubber. But then at first I was thinking, boy, these terminals are very close to this metal edge. But if you look close, they actually have something between the bus bar terminal and the metal container to isolate it. And they've got it there and down over here as well. So they really thought about this. Torque marks on their different connections to verify that they've been checked. Same thing with down here. Balance leads are all labeled. Temperature sensors are labeled on there. You can see them labeled on the PCB as well. Okay, so yes, right there. So B15/T4, temperature 4. So that has to be one of the temperature sensors. So we've got a temperature sensor there, right there. And then I would almost wonder, well, it's not marked on the PCB as a temperature sensor. So we at least have sensor 1 and sensor 4. Then this is packed in very tight. I can't really see the BMS. Down there looks like to be the contactor used to completely disconnect the BMS from outputting power. So some BMSs use MOSFETs to turn on and turn off. This looks like it actually uses a built-in contactor. I'm wondering if that's because of the high current draw requirement. And so that contactor is on the negative side of the battery. This is one of those ones that you're really not going to look at taking much apart on, especially if you want to use it. Sealant compound to make sure that nothing comes undone, nothing's jarred. Here's our Bluetooth antenna. So wire management looks good. All in all, I mean, it looks like a very well-designed battery. Very, very nice. I do like the PCB aspect too. It makes it look cleaner. And then I did forget to mention at the very beginning, but there is a thick gasket along the outside edge to ensure that it is watertight. So one other thing that I want to try and do before I close this up is see if I can get a shot of, very carefully, a QR code. And that says 02YC. So let's get a screenshot of that and take that over to the Global Power QR code decoder. Paste decode. It looks like it's missing some of the numbers, but it is saying that it is an EVE cell, 105 amp hours, 3.2 volt nominal. So it does say these are EVE cells, but I really don't want to go through and try and peel up more of this coating on here. It's very thick. It doesn't really want to bend very much, but that's good because it helps protect the upper section of the cells. Oh, I actually didn't notice this before. So, you know, we've got our terminal connection here, and then you can see, if I angle the camera right, you can see the traces on the board. And now I'm even wondering if it's even a board. It's hard to tell if it's just buried in this coating. But either way, so We noticed that this was the temperature sensor, but right there, that's your balance your balance lead connection. So you've got one there and there and there. So that's kind of neat to see. Let's see, can we get a better angle? There we go. So now you can see the traces, and then you can see it's coming over for the balance connection. So very cool. All in all, a very, very great looking build. I mean, somebody took pride in designing this. They didn't just slap it together like some batteries that we've seen even from other reviews. So they did a very, very good job on this. So I'm actually going to go and put the cover back on. And I'm actually going to put the cover back on in a different orientation than how it came. Because when I go to put it in the golf cart, I want it so when I open the lid, I can easily read the top of the battery. Because this is going to go on the passenger side of the cart for me. So, doesn't change anything other than makes the label easier to read. So a quick peek at the battery charger. We can see that it can output 58.4 volts at 20 amps. And it's designed for lithium iron phosphate, a 16S configuration. This is a waterproof charger, I believe. So it's got its quick connection for the AC input, and then a quick connection for the DC output going to the battery. And then there's an indicator on the side for what its charging state actually is. So it'll flash green when it's charging, and then when it is solid green, that means that it's either fully charged or it's waiting to be able to charge. So we'll take this quick connection. Blue is labeled as battery negative. Brown is labeled as battery positive. We're going to get those wired onto the terminals and then get this battery all charged up. And maybe we'll take a look at the app while it's charging. We'll remove these covers on the ends, just little rubber covers. And then you can really tell that they put some thought into this because they've got these quick disconnects for the charger. They also have different size lugs. So if I only wanted to hook up just the battery charger, I can use these shorter screws instead of the longer ones. Again, on our cable, battery negative is blue. So we'll go ahead and put that on right now. Tighten that down. And I didn't show you, but these screws actually have washers and lock washers on there to where they're not coming off, which is really nice because I have a tendency to lose all these stupid little washers that go on these screws. And we will put the brown side on our battery positive. Remove our little cable management strap that comes on the cord. It's Velcro and it's sticking to my glove. There. So we'll take our quick disconnect for the AC, connect to the battery charger. Quick disconnect for the DC. And that looks like it's just a twist lock on here. So you see how on here there's a little cutout, little half circle cutout? Well, there's a corresponding spot on this side. So line them up, and when you push them together, this blue piece twists and locks them together so they can't come undone. If you need to take them apart, you will twist this blue lock to unlock it, and then you can pull apart. Nice and simple. But again, in a vibration-prone environment, you want to make sure that everything stays connected. So we're all connected. Let's turn our battery back on. I heard the click. Press the button on our display just so we can see what's going on here. And we will plug into the wall. So the charger clicked. There's a fan kicked on. Can you see the blinking green light right here? And then on our display, it says that we are charging with 2 amps right now. Excuse me, 20 amps. I'm reading upside down. That's really bad. It's not 2.02 amps, it's 20.2 amps. So if I press the button, still normal status, good temperatures, and then on this page it does show us which one is our high cell and then which one is our low cell. So green is the high cell and blue is our low cell. Oh, I even missed this on the bottom here. Hopefully you can actually read it. But it says time to full 2 hours and 51 minutes. And again, while it's charging, take a look at this app card that they give us. So we need to search for a specific app. The Xiaoxiang, I don't know if I'm saying that right or not, and install the electric app. So if you search for it, you'll see 2 of them. There's a BMS one and then an electric one. You'll want the electric one. I think you can do it without the electric one though. We'll find out here. But here's what the information it's gonna give you. It's basically just gonna give you the specs of the battery itself. Because I already have the BMS app installed on my phone, so let's see if that one works for this one. So on my phone, here we go. Open up the BMS version of the app, and it's going to be this top one, which gives me the actual serial number, and it's actually on top of the battery itself. So we'll tap that one to open it, but we're charging with 20.2 amps, 53.79 volts. We've had 1 battery cycle, 1 single cell over voltage, and 2 single cell under voltage so far. This was manufactured October 9th, 2024, which is sweet because we're a little over a month and a half old. So we can read the values of the configuration. 105 amp hour capacity. It says that the cell is full at 3.55 volts. Balancer starts at 3.3 volts. A little low for me, but I'm used to seeing that at 3.4, 3.45, and it'll balance down to 15 millivolts. So that's good. Take about 3 hours, but I'm not staying up till 1 a.m. One reason why I like the BMS version of the app over this one is I'm not really a fan of having to create accounts just to see what the BMS is doing. So if I can do it without creating an account, awesome. But if you don't mind, here's the instructions on how to get that app and then what you can see in that app as well. Hopefully you're not seeing any spaghetti sauce on my face. I tried to get it all cleaned off. We just got done eating dinner. So we'll be back tomorrow. Let this thing charge overnight. Get balanced. I mean, it actually looked really good from the app and even the display. So let it get all charged up and balanced, and then we'll connect it to an inverter and do a full discharge test. Make sure we can get 105 amp hours out of this battery before it shuts down. So everything charged up last night. We can see we've got our solid green light here on our charger. Display button, 100% charge, 54.6 volts. But I noticed that the cells were kind of out of balance. So I came into the app and I was at 116 millivolt deviation, and I had a cell warning that a cell was over voltage. And I must have completely missed this yesterday, but if I go to config and BMS settings, read the settings, and scroll down, I missed this, that it's balance only when charging is enabled. I don't like that because as soon as your cell hits an over voltage, it stops balancing. It could be just a mess on your cell configuration. So I turned that off, and we can see now that it's going through and it's balancing all these cells to try to give me more capacity, and it'll let me maybe eke a little more out, get a good top balance on this. So I want this to actually get balanced out before I go through and run this discharge test. I want it to sit on this and level out. We're at 116 millivolt deviation right now, so it's dropping slowly, but you can see cell 7 is a high cell right now. So that would be one suggestion that I would make, just to turn that option off so that it will balance your pack even if it hits a cell over voltage. All right, so you can see we're at 15 millivolts deviation right now. Almost perfect. That cell number 7 is still the one that's higher than the rest. Needs to kind of balance out a little bit. All right, so we're gonna get our discharge test started here. So we've got our battery connected into my test wall. My midnight inverter will be the inverter supplying the power from the battery going into my 30 amp breaker, which runs down to my charge inverter, and then that dumps the power into my main battery bank, so I'm not wasting the power. Charge inverter is currently set at 21 amps, which is a 0.2C rate for discharge. I've already gone through reset the shunt, so when we turn this on, it should supply power to the inverter. Once that turns on, then I can turn on the 30 amp breaker. So let's get started. So there's a click on that. The inverter just turned on. We can see our voltage is 53.34 volts. Now that says that it's discharging. And you just hear the fan kick on for the charge inverter. And we're pulling 24 amps out of the battery. 25. So we'll make an adjustment to get that right down to around 20 amps. We'll see how it goes. Time to go, 5 hours, 4 minutes. Boy, in here I thought I was getting down here just in time. Ran down the stairs. Missed the last step. Nearly twisted my ankle getting down here, and I thought I was going to have at least 3 minutes left. And as I was getting the cameras ready, we hit 0. And everything shut down. So the pack bounced back. It's up to 45 volts, but there's really nothing drawing off of it right now. And we hit 105 amp hour discharge. And we can see that here on the history page as well. So we have a full discharge. And in fact, we might have actually been able to hit 106 had I reset this properly. So either way, we hit maximum capacity. We got that 105 amp hour discharge, which is awesome. And if I tried to go a little further, I could probably get 106 out of it easily. But it's all right because we hit 105. We hit the rating. So the last thing that I wanted to take care of tonight, I attempted to test the low temperature charging protection by taking one of those cold packs for a kid's lunchbox and putting it on one of the temperature sensors earlier. But it's so hard and rigid, it couldn't envelop the temperature sensor. I don't have any of the compressed air to try to spray on it. So I was racking my brain thinking, well, you know, this battery's going to be outdoors, so how do I test the low temperature charging protection? I opened up the freezer. The freezer's full of food. There's no room in the freezer to stick this battery in the bottom. And then I had a light bulb moment. Since my freezer's full, we're going to use the freezer that God created, the Michigan outdoors in winter. So we're just going to leave this thing outside for the night. It's supposed to get to 28 or 29 degrees Fahrenheit tonight. So that should help this thing get a nice, good chill. And then come first thing in the morning, we grab it, take it inside, put it on the charger, and see how it does. I did end up putting a little bit of power in this battery just so it's not sitting out here completely drained in the cold. Well, I was wrong. I just got done taking care of the stove, the critters, and it got colder than 28 or 29 last night. I think it got down to like 25 or 26. I don't know if it's going to focus or not, but right now it says that it's 28. And we've got nice layer of frost on all the panels. So let's find out how cold this thing is and see if charging is disabled. Because that's going to be the key factor. We want to see what the temperature is and then make sure that the BMS actually disabled charging. So we'll plug in the display. Whew, that's cold. Even leaning on that thing is cold. All right, let's see what we've got here. If we can get it without the glare. So 5%. It says that it's 37 degrees. And the lowest is 34. So it's not cold enough to turn it off yet. Which makes me wonder how accurate these temperature sensors are. Because yeah, it's warming up. So unfortunately, I don't have anything right now that I can use to actually test this to see if it's actually going to turn off. I have seen it in other videos that it does turn off, but I don't have the ability to test it. I was hoping that coming down to 26 degrees outside, it would have made this drop, but for whatever reason, obviously this is thinking that it's warmer than it actually is. And I can't imagine that the BMS is putting out that much heat, that it's keeping the battery warm. So the app says 35.4 for temp sensor 1, 36.5 for 2, and 37 for temp sensor 3. So I guess just keep that in mind, that it might actually have to get colder than what you think it is before it stops charging. Because this thing's been sitting outside for the last 9.5 hours. Plenty of time for it to acclimate to whatever the temperature outside is. And it's not in an enclosed space, it's open air. So just keep that one in mind. So final thoughts on the Vatrer 5.2 kilowatt hour golf cart battery. As this thing warms up and thaws out. I mean, very first impression that I got when I pulled this thing out of the box was, wow, this looks well built. I mean, the metal cabinet that this is in, the attention to detail that we saw when we opened up the top and looked at the bus bar configuration, the wire management, just the little things, even like the fact that, you know, the bus bars are getting a little too close to the case over here, so they put an isolator along the back wall of the case. Somebody took a lot of time in designing this battery, and I think they did a really good job. I think I forgot to mention this, but this does come with a 5-year warranty. And that's not bad if you think about it, because this is really going to be kind of exposed to the elements if you're putting this in a golf cart. So a 5-year warranty where this is going to get jarred, jostled, wet, potentially, that's not bad. The fact that this is really meant to be a drop-in replacement for a golf cart battery, well, honestly, I'm looking forward to testing that one out, because I've got, I think, 6 lead-acid batteries that have to come out of a cart, and this is getting dropped in. If I didn't have a golf cart, I could take this and I could tie this directly into my existing solar banks, because this is a 48-volt nominal battery. So you could use this, and even something to think about, because we talked a couple weeks ago on a live stream about kind of like emergency power. And if you had a golf cart with one of these in it, and you had a 48-volt system in your house powering your house, if your batteries get low, you could utilize the power out of this battery. In fact, that's what I did for the discharge test. So that's, you know, another plus in my book. It hit its rated capacity, 105 amp hours, no problems. In fact, I think I probably could have squeezed a little bit more out of it. This thing is supposed to be able to surge up to 400 amps for 35 seconds. And we saw it's not MOSFET driven. It's got a giant contactor in there that they're using for disconnecting. So something different in there. Never seen one of those before. Seen relays, seen MOSFETs, but not the contactor. If I had to find a couple of negatives about this battery, I think one would probably be the fact that we saw balancing is only enabled when the battery is charging. And I see that being an issue just because, well, even in this pack, if you get one cell that gets over voltage, it's going to prevent charging on the battery, which is then going to stop your balancing. So your pack is going to stay out of whack until it self adjusts, and then it's going to turn the charger back on, and you're going to go through that cycle over and over and over again. If they raise the balance voltage to 3.45 volts, and then have it always balance when it's above that threshold, then we can always have a nice top balanced pack. The other thing that I'd probably mention is the temperature sensors might be about 4 or 5 degrees off. I had this thing outside for 9-10 hours last night in the cold, and even when I put it outside it was 30 degrees. So it's been 30 and below for the last 9 hours, and yet the temperature sensors on this still thought that it was 34-ish and above. So if you have it in a cart, in a garage, it'd have to get pretty cold for it to hit that temperature disconnect. But again, just something that I think could probably be tweaked. But other than that, I mean, it's a full replacement kit. You get the charger, you get the display, you get the battery. That's not too bad. So I'm actually looking forward to putting this to the actual discharge test in a future video where I take this and do a full replacement on my pastor's club car Precedent and swapping out all 6 of his flooded lead acid batteries with one Vatrer 5.3 kilowatt hour lithium iron phosphate battery. That one's going to be fun too. If the performance on this is anything like the build quality, then this thing should scream. So I'll leave links to this down in the description below. They do have different types of golf cart batteries that can be drop-in replacements for other model of golf carts, not just the club car. So take a look at those. If you have a lead acid golf cart and you're just tired of dealing with the maintenance and finally want to pull the trigger on a lithium battery, they've got some Black Friday deals going on. I believe they've given me a discount code for 5% off, so I'll make sure to link that down in the description below. Take a look for yourself. I am pleasantly surprised at the quality of this battery and look forward to putting it to actual use. So with that, I'm gonna let y'all go. Y'all stay safe, stay warm, and we'll catch up with you later.